Okay, so we'll take the second question now. So question number 2. A rectangular pier of width 200 mm and thickness 150 mm is subjected to an eccentric load of 60 kN at a distance of 20 mm on axis bisecting the thickness. So this is the location of that eccentric load. Now what we have to find? We have to find maximum and minimum stresses. So now in this question what it is given, that a rectangular pier is there. The dimensions of the pier are given. This is 200 mm and this is 150 mm. Then it is subjected to an eccentric load. So it is not a direct load now, it is an eccentric load, and the location is given. It is present on axis bisecting the thickness. Now which is the thickness here? 150 mm is the thickness. So an axis bisecting 150 mm means you have to draw a line which will divide 150 mm into two parts. So it is nothing but the x-axis. This is the centroid. So it is given that the given load, it is present on this x-axis. So this is the location of the load. So if you draw it in the elevation, it will be present here. So this is the location of point load. The value is 60 kN. Now what is this distance? This distance is the eccentricity and the value is 20 mm. Now the first thing given, so here point load is given of 60 kN. So you can write it 60 into 10 to the power 3 Newton. Kilo means 1000. So then after B 200 mm, D 150 mm and E 20 mm. So to find, so we'll find two things here. First is sigma max and the second is sigma minimum. So we'll start with finding out the direct stress. We know that direct stress sigma naught is equal to P divided by A. So P is 60 into 10 to the power 3 Newton, 60 kilonewton, and area is B into D, 200 into 150. So this should come as 2 Newton per mm square. So this is the value of direct stress, that is sigma 0 is equal to 2 Newton per mm square. Now second is bending stress. Bending stress is denoted by sigma B. Formula is m divided by z. Now in this case the load is present on x-axis. If the load is present on x-axis, then we should take zy. So this should be m divided by Zy. This M is nothing but P into E, and the formula for Zy is dB square by 6. dB square by 6. We have derived this all the formulas in the previous classes. So if you have not seen the video, you can see the previous videos, you will get the answer. So for rectangular section, Zy is dB square by 6. So substituting all values here, 60 into 10 to the power 3 into 20 divided by 150 into 200 square divided by 6. So on calculating, you should get the answer as 1.2 Newton per mm square. So sigma B is 1.2 Newton per mm square. So this is the value of bending stress. Now final answer, maximum stress. What is the formula? Direct stress plus bending stress, and minimum stress is direct stress minus bending stress. So maximum stress, direct stress is 2, bending stress is 1.2, 2 plus 1.2 is 3.2 Newton per mm square. Similarly, bending stress is, direct stress is 2, bending stress is 1.2, 2 minus 1.2, 0.8 Newton per mm square. Now as it is positive, both the values, we can write it like this, 3.2 Newton per mm square in bracket compressive. Similarly, 0.8 Newton per mm square compressive.